Let's understand indexes in SQL. Without an index, SQL performs a full table scan. It checks every row one by one until it finds a match. That's fine for 100 rows, but terrible for 10 millions. When you create an index, SQL builds a B tree, so a balanced tree, so it can find data fast. So how does a B tree work? Let's say we have a number 40. Every B tree has a root element. Let's say 40 is our root element. Let's add the numbers 30 and 50 to our B tree. 30 will be assigned to the left, since it is less than 40, 50 to the right, since it's bigger than 40. You could add a couple of elements there. We can also add another leaf. The same rules apply here as well. If the number is smaller, it will be a leaf to the left of the number one level higher, otherwise it will be to the right. Finding an element in a B tree is a lot faster than going through a random list, since you exactly know which path you have to take to find a specific element. If we wanted to find 5, for example, we could just compare the number to a given number in the tree. If the given number is bigger, we have to take the left path, otherwise we have to take the right path. We could also replace numbers with text, for example, and it would still be the exact same. To find a name starting with the letter A, for example, you would just need to take the left path. So let's create an index. But before we create an index, when should we even create an index? Should we always create an index for every single column, or is there a specific rule? In general, if you want to use a column to do a lot of reads, it might make sense to add an index. Otherwise, it's probably not the best idea. And the reason for this is that every time you write into the database, you also have to update the B tree. So if you don't really get the benefit of having a lot of reads using that column, all you really do is slowing down the writing process into the database, which is obviously not too good. Why does the database writing get slower when adding indexes? The reason for this is that you do not only have to update the database, so not only the tables, but you also have to update the B trees every time you write into the database. Because obviously you're getting new data. This data needs to be inserted into the database, but also needs to be inserted into the B tree. And the entire tree needs to be updated to keep it consistent. But now let's, for example, take a look at our users table. Let's execute, and as you can see, I prepared a users table that has 54 entries. So we have a lot of users right now. If we wanted to explain what is going on right here, we can use the explain keyword. So let's execute that one. And as you can see, we are now getting a little bit of description on this query. We get the select type, for example, the table, the type, possible keys, and so on. And as you can see, we also get the amount of queried rows. And in our case, we queried 54 rows because we're outputting every single user. So now let's take a look at every single user, and let's say we wanted to get the user that has the username Tom07, for example. So we say where username is equal to Tom07. Now let's execute that one. We're getting the user. Now let's explain that one. Execute that one again, and as you can see, we queried 54 rows. So that is pretty inefficient if you think about it. We queried 54 rows to only get one single user. So in this case, let's add an index. We can create an index by saying create index. Now we need to define the name of the index. So index underline username, for example. On which table do we want to create this index? In our case, we want to create that one on the users table. And the specific column is username. So let's execute that query. Everything seems to work, so we can show our indexes by using show indexes from users. So we show all indexes from our users table. As you can see, we're getting an index for email and also an index for username. And as you can see, this index right here is the index that we've added because it has the key name index underline username for the column username. So now let's again select everything from users where username is equal to, and I think it was Tom07. So let's execute that one and see if we get a result. As you can see, we get the user. And now let's explain that one again. Execute that one again. And as you can see, now we only queried one row. And the reason for this is that we use the by tree to find the user. Since we have the by tree, we know the exact position of the row where Tom is located, and we can just go to that position and get the user. So now getting a user by using his username is a lot faster. But again, this will also slow down our writing process. So it has some pros and cons. If we wanted to delete an index, we could say drop index username, so the index name, on which table do we want to drop that one? On users. So we are going to execute that one. The query worked. Now let's again show indexes from users, execute that one. And as you can see, we only have 2 indexes left.